will next look at an example of list in C, and there are of course numerous different kinds of lists, such as those here. So let's look at the circular double linked list. What this means is that there is no point with a null pointer that terminates the list. Instead, it's just goes around in a circle. And we have one pointer to the next node, suk, for successor, and one pointer to the previous node, the predecessor. We start with declaring the following type name list, this list T. There is a convention in C, as you have noticed, to give the name to a type with an underscore T. Okay, so we start with saying that this list T is a synonym to this type. We do that with typedef. And typedef simply creates a synonym. It's not a different type, it's a synonym, which means if there is a rule that we cannot assign between different between pointers to different types. But for instance, if we have different type names, they are still the same type. So it's just the name and doesn't change the real type. Okay, so what happens now? We introduce an incomplete type struct list. And now we define this type to make it complete. So we say struct list, and as you can see here, we don't need to type struct any longer. And you may ask yourself, why don't we skip struct there as well? Well, it is because Dennis Ritchie decided that the grammar should look like this. And it makes parsing C programs much easier. Okay. So if we want to create a list node, we can allocate memory like this. We should actually check if list is a null pointer or not, and let's keep the code as simple as possible and skip that error check. But what we do is to request as many bytes that are needed for such a struct. Now it's very important not to say size of list pointer, since it's not the pointer, it's the complete struct that we want, even if we use it for a pointer. I mean, list should point to such a struct. Now we see some funny syntax, and in Java this would be written just with a dot instead of the arrow. But in C that's not possible, and the reason is that the dot is used for a struct attribute, but list is not a struct, it's a pointer to a struct. So if we look at this part, then we can use the dot notation, but we need to use a star in front of the list pointer. So the type of this is a struct. So therefore we can use the dot. And originally in C, this was the syntax for when you have a pointer to a struct and want the attribute. After a while, it was too tedious to write this, and it doesn't help readability. So this syntax was introduced instead. So if we have a pointer to a struct, then we can write this arrow and the attribute. So what does this really mean? It means that we have a struct with suc and pred and data, and then we have the list. So that's one box in memory, and then we have the list. Okay, and it points to the beginning here, but we can specify any attribute that we want. So what happens is that we use this pointer and add a constant, I mean not we, but the compiler, that corresponds to how many bytes in this struct the attribute is located. I would recommend to start using this syntax because it makes it very concrete what we are doing, and then when you get used to that, switch to this. If you want to, but well, you should, because otherwise the code will look very odd after a while.